Well, it's very helpful to have a calculator for the normal distribution. Obviously, the normal distribution is not the only parameter we're going to be using as we work our way through statistical analyses. So it pays to take this idea of a quick calculator, start to apply it to other distributions. So let's try building one for another distribution now. I'm going to take this calculator, I'm going to copy it over here. Again, it might be faster to retype it than to do anything else here, but let's assume we're going to do the exponential distribution. So I'm going to not use this norms dist function over here to do my work. So I'm going to take it out so I don't accidentally use it over time. And there is no inverse function for this in Excel, so I'm going to get rid of my inverse function from the first. X bar and S are not the parameters for the exponential distribution. What I need is my lambda, if I can spell lambda correctly. So let's assume an to say is 20 per hour. And then I typically know my mu. So my mu is my inverse of my lambda coming in. Now mu isn't actually a parameter of the distribution, so I don't want that in red because I can just calculate it from what I've got. So I'm going to turn that back to my black value as I go through. So again, I've got an A and a B value as I go through. The exponential distribution doesn't use a Z value, so I can take those cells out of there as I go. And I'll be able to plug in my value. So if 20 per hour is my rate, or about 3 minutes each, let's assume that I'm going to look for something between 0.0, a minute and a half maybe, and 4 minutes. So 0.075, so it's the range I might want to look at. So what I want to do here is the exponential distribution, which requires me to know my x. It requires me to know my lambda. I'm going to lock that in so when I copy the cell it won't move, and to take the true value of the curve. So if my lambda is 20 and my mu is 0.05, the probability of a value being at or less than 0.025 is roughly 39% as I go through. Now I'm going to take that same calculation over here. And the probability of being less than 4 minutes is 77%, and the probability of being from a minute and a half to 2.5 minutes is 38%. So there's my basic calculator for the exponential distribution, created in just a few minutes from the function that's going on, because the basic structure of these spreadsheets is more or less the same as you build them. It's just a matter of plugging in a different distribution as we go. So like I said, just for the sake of discussion, let's take another one now. So I'll copy my cells over because that's often the best way to do this. What if I want to take the Weibull distribution now? Okay, as my basic parameter, and it has two parameters. The alpha parameter and the beta parameter, which might be, say, 2 and 10. And now the beta parameter is a parameter, so I'm going to put that back to red for some consistency as I go through. Let's assume I might have a value of maybe a 10 and an 11 on this basic distribution as I go through. So what I've got here still, notice, is the exponential distribution. I don't want that. So whenever you copy the cells, first thing you should do is take out the distribution you're not interested in, because I want to substitute another one here, another Weibull distribution, to take that x value with my alpha, which I'll lock in. I'm pressing F4 to do that if you don't know Excel. And my beta, which I will lock in, and I'll take the true value of that as well. So there's my probability. I'm going to copy it over here to do it again. So on a Weibull distribution with an alpha of 2 and a beta of 10, the probability of being 10 or less is 63%. The probability of being 11 or less is 70%, and therefore the probability of being between 10 and 11 is 0.06 as I go through. So now the Weibull distribution has one other parameter to it that we might want to insert a line here. Because often you'll see in terms of an offset called gamma, because the Weibull distribution has a floor at 0, and often the data you've got doesn't have a floor at 0. So the default might be a 0 parameter here. So a 0 gamma simply means that there's no left-right shift going on. And the way we adjust our formulas is we subtract gamma from the x value that we're working with. So recopy myself. So if gamma is 0, I haven't changed the values, but if I were to shift my data score, say by 4, I shift the probabilities going through. So you'll often see a gamma function being used as a third parameter to a Weibull distribution. It simply represents the left-right shift. So if you don't see that in a problem, if you're using this little calculator and you don't see a gamma value anywhere in your data, just always enter 0 for this value to show no offset, because the Weibull distribution varies from 0 to infinity, but often your data does not. So often your data, when it does fit a Weibull distribution, is actually shifted. So when you're doing your probability plots and trying to figure out if your data fits the Weibull, keep in mind that your data may be shifted plus and minus. So often if you take the smallest value in your distribution and presume that's a gamma function, then you'll shift the data enough that you'll get a better fit to the Weibull function as you go through. But as you can see, as you build these little spreadsheets, they build very, very quickly. If you've got one function built, like I started with the normal, I could very quickly come up with an exponential version of that, and then copy that and come up with a Weibull version of that. So if you're creating tools for yourself, you want to be able to quickly do these kinds of calculations, just keep going. Start pulling in other distributions, the gamma, the beta, the log normal. Any distributions you tend to use much as an engineer, just add them to your spreadsheet as you work your way to the right, and you'll be able to calculate these probabilities much faster from a problem you're dealing with than having to stop and recreate these little tools every time you do your work.